In yesterday I made a lot of cobblestone and I'm nearly ready to start to build my castle, at least first buildings. In yesterday I actually made quite a significant progress. I made more of these furnaces in order to store some items because this is the only way for me to store some items now. I also made some first copper items and I also made so much more of these furnaces because again this is the only way to store items. Now it's raining and the rains here are pretty long actually, really. It might take like one day, long day, or like even 2 days, so I do not know when it's gonna end. But yeah, I've got so much of cobblestone, like this is a huge amount. I cannot believe that I made this furnace, brick furnace. It's not so difficult. You need some bricks and also glass and iron, a little bit of iron. I literally got iron from that place yesterday, and that was the only iron I found so far. And I was so lucky actually, really. Only because of that little chunk there, I've been able to make this furnace, which is faster, and I'm able to store 2 items, 2 slots, instead of 1. And it's faster. As you might see, there are some puddles, and sometimes they are strange, but there are many of them.
They respond when something over on my right happens, like I'm snapping my fingers over to my right, snaps over my left, which is the whole thing into itself. Over there on the left side, but when I do that, there are different neurons respond to this. We have a map of visual space. Certain neurons are seeing things in certain portions of visual space and not others. We have a map of motor space, meaning when we move our limbs in particular directions, we know where those limbs are because we can't see them. We have what's called proprioceptive feedback, so we have knowledge about where our limbs are. In fact, people that lack certain neurons that for proprioceptive feedback, they are very poor at controlling their motor behavior. They get injured a lot. It's actually a terrible situation. So we've got all these representations inside, and we have maps of our motor commands.
I'm just waiting for rain to end. I don't know what to do.
Generate a certain amount of force, so I rarely overshoot. I rarely miss the bang. Okay? So our maps of the motor world and our maps of the sensory world are converging. The way to create plasticity is to create mismatches or errors in the world. And this, I think, is an amazing and important feature of neuroplasticity that is highly underappreciated. The way to create plasticity is to send signals to the brain that something is wrong, something is different, and something isn't being achieved. I think this will completely reframe the way that most people think about plasticity. Most of us think about plasticity as, okay, we're going to get into this optimal learning state or flow, and then suddenly we're going to be able to do all the things that we wish that we could do. Well, I hate to break it to you, but flow is an expression of what we already know how to do. It is not a state. And I'm willing to go to bat with any of the flowistas out there that want to challenge me on that. Flow is an expression of the nervous system capabilities that are already embedded in us. Errors and making errors out of sync with what we would like to do is how our nervous system is cued through very distinct biological mechanisms that something isn't going right, and therefore certain neurochemicals are deployed that'll signal the neural circuits that they have to change. So let's talk about the experiments that support what I just said. I'm about to tell you that making errors over and over and over again is the route to shaping your nervous system so that it performs better and better and better. And I'm not going to tell you that the last rep of a set where you make failure in the gym is anything like neuroplasticity. You hear that too, that it's pushing to that point of a cliff where you just can't function anymore. That's the signal. That's not the signal. That's a distinct neuromuscular phenomenon that bears zero resemblance to what it takes to get neuroplasticity. So let's talk about errors and making errors and why and how that triggers the release of chemicals to then allow us to not just learn the thing that we're doing in the motor sense, like piano, dance, etc., but it also also create an environment to feel you within the brain that allows us to then go learn how to couple or uncouple a particular emotion to an experience. It's a falsehood that everything that we do in experience changes our brain. Brain changes when certain neurochemicals, namely acetylcholine, norepinephrine, and dopamine, are released in ways and in specific times that allow for neural circuits to be marked for change, and the change occurs later during sleep. I'll review that later, but basically, you need a certain cocktail of chemicals released in the brain in order for a particular behavior to really shape the way that our brain perceives. It's actually a signal that tells the brain, okay, it's time to change, or more generally, it's time to pay attention to things so that you change. And I really want to distinguish this point very clearly, which is that I'm going to talk today a lot about motor and vestibular, meaning balance programs, but not just for learning motor command and balance, not just for learning motor skills and balance, but also for setting stage or a kind of condition in your brain where you can go learn other things as well. We're mostly going to be talking about adult plasticity today, but I got a lot of questions about, well, what about if I'm younger than 25? First of all, it's great. I wish I had a time machine, but I don't. Because as I've said before, the stinger is when you're young, your brain is very plastic, you have less control over your experience. When you're older, generally you have more control over experience, but your brain is less plastic. So you're already asking the question, as a 20-year-old or a 15-year-old, what can I do now that's really going to enhance my brain? I guess the simple question would be, an aside, which would be get the broadest education you can possible. That means math, chemistry, physics, literature, music, learn how to play an instrument. I'm saying that I wish I had, etc. Get broad training in those things and find a ton of additional effort there. That's what I recommend, including emotional development. Maybe a topic for a future episode. But if you are an adult or if you are a young person, knowing how to tap into these plasticity mechanisms is very powerful. You need these chemicals deployed in the nervous system in order to mark whenever nerve cells happen to be firing in the time afterward for change. And people are obsessed with asking what supplements, what drugs, what conditions, what machines allow for that. There's a natural set of conditions that allow for that. When we came into this world, we learned to take our different maps of experience, our motor maps, our auditory maps, our visual maps, and to link a line. I look to my left. In front of me, in front of me, I hear it behind me, I turn around. And that's because our maps of visual space and our maps of auditory space and our maps of motor space are aligned to one another. It's an incredible feature of our nervous system that takes place in a structure called the superior colliculus. I don't know if you know that name. The superior colliculus has layers, literally stacks of neurons, like in a sandwich, where the 0 point right in front of me, or maybe 10 or 15 degrees off to my right, or 10 or 15 degrees off to my left, are aligned so that the auditory neurons, the ones that care about sounds, at 15 degrees to my right, sit directly below the neurons that look at 15 degrees to my right in my visual system. And when I reach over to this direction, there's a signal that sends down through those layers that says 15 degrees off to the right is the direction to look, it's the direction to listen, and it's the direction to eat. So there's an alignment. And this is really powerful, and this is what allows us to move through space and function in our lives in a really unique way. Set up during development, but there have been some studies that have revealed that these maps are plastic, meaning they can shift, they're subject to neuroplasticity, and there are specific ways that allow for shift. So here's the key experiment. The key experiment was done by a colleague of mine who's now retired,
That is so
but
fast.
absolutely
Wow.
fundamental in the field of neuroplasticity, Bernard Knudsen. The Knudsen lab and many of the
Thank you guys so much.
showed that if one is to wear prism glasses that shift the visual field, that eventually there'll be a shift in the representation of the auditory and motor maps too. Now, what they initially did is they looked at young subjects ask the animal subjects or whatever to reach for this object, and they reach to the wrong place because they're seeing it where it is. This gets especially complicated when you start including sounds, when you have a thing off to your right making a sound, but the thing is actually right here. So you're hearing the sound at one location and you're seeing the object at another location because you're there. So your image of the world is totally distorted. Or, in experiments done by other groups, they wear glasses, subjects wear glasses that completely invert the visual world so that everything is upside down, which is an extreme example of these representation of maps being represented so that they always reach to the correct location. So they hear a sound at one location, they see the object that ought to make that sound at another location, and they somehow are able to adjust their motor behavior to reach to the correct location. It's incredible. Absolutely incredible. Or in the case of the people who look at the world upside down, they somehow are able to navigate this upside down